Hello, hello students. So this chapter is on plane strain and strain transformation relations and strain Rossets. So plane strain means all the shape changes are confined in a single plane. So if that plane be the xy plane, then epsilon xx, epsilon yy, gamma xy, they are non-zeros. But epsilon zz, gamma yz and gamma zx, they are zeros. So this is plane strain condition. So suppose you take this yellow element. So this element, this is parallel to the x-axis. So this gets extended. So this is epsilon xx and this is positive when there is elongation. And this is dy, and when this get extended in the y direction, so then epsilon yy is positive and gamma xy is positive if this yellow one is before deformation and this dotted one is after deformation. When after deformation, the angle between these two fibers which were initially parallel to x and y axis reduces, then it is positive shear strain. So generally plane strain is actually a simplifying assumption, and we do it for these type of cylinders which are subjected to internal and external pressures and which are restrained in the z direction. These are long cylinders restrained in the z direction so that there cannot be any movement in any displacement in the z direction. That means at each cross section we assume similar deformation, similar shape of deformation, similar shape change occurs at each cross section. At each cross section, we at least a little away from the ends. So in this case we use the simplifying plane strain assumptions. Also we use in case of long dams where there is water pressure from here and this end and this end, they are restrained. So we assume that at every cross section of this dam same shape changes occur and perpendicular to that no shape change is there. So this is a simplifying assumption and this is true a little away from the ends, because at the ends there may be end effects. So now what are these strains? Suppose in a body we take a fiber or an element of very small length, infinitesimal length dx, which is parallel to this x-axis. Then this point, then after deformation, this point comes here, and this point is having a displacement in x direction and displacement in y direction. The displacement in x direction we call it u, and displacement in the y direction is called v. Both are functions of x and y. So at this point this is v and this is u. The orange one is u and the pink one is v. So at this end, what would be the displacements then? There will be a change in u, and the change in u, since we are going in the x direction, so u would be u plus rate of change of u with x, rate of change of u with respect to x into dx. So this is that. And what is this? So this is v, this is v plus, this is v. So v plus rate of change of v with x into dx. So this blue dx becomes this green line. Now what is the length of this green line? The length of this green line is, so this length square plus this length square root over. So what is this length? This length is u plus dx plus u plus del u del x dx minus u. So that is this dotted green line, the length of this. So this is u and this is u, and up to this it is dx. This is u plus del u del x. So this from here it starts. So this is u plus dx plus dx plus u plus del u del x minus ux. So it is dx plus del u del x dx, and then this is v. So this is del v del x dx, del v del x dx square. So if you now, so this becomes something like this. So these are higher order terms because square of different del u del x and del v del x. So these are small compared to this. So this becomes dx into 1 plus del u del x. But before that, we make a linear, make an expansion. So this is 1 plus this to the power half. So 1 plus half du dx, half 2 du dx, which makes it 1 plus du dx plus half this plus half this. So we make an expansion, we take the first term. So that means this is the final length. This is the final length. So final length minus initial length is the elongation, is the change in length, or is the elongation, and this is divided by the initial length. So epsilon xx is del u del x. So in this way you can, if you take this dy is parallel to y-axis. So this is u, this is v, and at this point, this is, if this is u, this should be u plus change in u with dy. So u plus change in with rate of change of u with y is del u del y into dy, because we are going dy distance. Similarly, this is v. So here displacement is v. So v plus del v del y, that is rate of change of v with y. Now here you notice that we are going in the y direction. So del v del y into dy. Now again you follow the same procedure and you show that epsilon yy is del v del y. And for gamma x, you just take this point. So you take these two lines. The length of this line is dx and the length of this line is dy. So this is 90 degree. So initially this was this point. So before deformation, this was the point, and after deformation this goes here. So this is u and this is v, and this end goes here and here. So what is this? This is the change in u. So this is u. So rate of change in u with respect to x into dx. But what is this? This is v. So rate of change, so v plus rate of change of v with respect to x into dx. And what is this? This is similarly, we are going from here to here. So this is u. So this is u plus rate of change of u with respect to y into dy. So this is this. So now how much is from here to here? From here to here it is del u del y dy, and from here to here it is del v del x dx. So what is this angle? So this angle is tan of this angle. So sorry, what is tan of this angle? tan of this angle is this. This means del u del y dy divided by the base which is dy. So the tan of this angle is del u del y, or this angle, when this is very small, this angle itself can be called to be assumed to be del u del y, and this angle as del v del x. So from initial 90 degree, the change is this plus this, and this change is del u del y, and this change is del v del x. So gamma xy, or rather you just write xy, gamma xy, not tan, gamma xy is this. So or this. So this is the expression for shear strain. So now we know what is the normal strain and shear strain. Now suppose this is one xy coordinate system and this is another x dash y dash coordinate system, and angle between these two is, and the angle between this is theta and theta. So we know that x dash to y dash equal to cos theta sin theta minus sin theta cos theta xy, or xy is cos theta minus the transpose of this cos theta minus sin theta cos theta this. So now del x dashed is del x dashed plus del y dashed, because x dashed is a function of both x and y. So del x dashed would be del x dashed plus del y dashed, del y del x dashed. So what is del x dashed? So here see x equal to cos theta x dashed plus or minus sin theta y dashed. So del x dashed is only cos theta. So this is cos theta del x, and del y dashed y is sin theta x dash plus cos theta y dash. So del y dashed is cos theta. So this is del x dashed, and del y dashed, this is an operator, this will operate on something, some u or v or u dashed or v dash something. So del y dashed similarly we can write as minus sin theta del x plus cos theta del y. Now see again in the same direction as x dashed y dashed, if we take u dashed and v dashed, u dashed would be u cos theta plus v sin theta, and v dashed will be minus u sin theta plus v cos theta. Now what is epsilon x dashed? It is del u dashed del x dashed. That means del x dashed of u dashed. And what is u dashed? This. And what is del x dashed? This, which we have already obtained from here. Del x dashed is this. Now you just cos theta del x of u cos theta. So cos theta does not depend on x. So that means del u del x. So cos square theta del u del x plus cos theta sin theta del v del x plus sin theta cos theta del u del y plus sin square theta del v del y. And if you just simplify by using the standard trigonometric identities, you get this is epsilon x dashed equal to epsilon xx plus epsilon yy by 2 plus cos theta cos 2 theta epsilon xx minus epsilon yy by 2 plus sin 2 theta gamma xy by 2, or this one. You call this the average sigma. So this is the transformation relation for epsilon xx. That means if you know epsilon xx, epsilon yy and gamma xy, then at an angle, and if you take another axis x dashed y dashed, where x is the angle between x dashed and x is theta, then you can get epsilon x dashed using this relation. Similarly, you can proceed for gamma x dashed y dashed. Gamma x dashed y dashed is this. So del y dashed is minus sine theta del x plus cos theta del y. Now for the first term, for the first one, this operates on y dashed. So this is y dashed. So now you proceed just like before. Now del b dashed del x dashed. So this is, now add these two, del u dashed del y dashed and del b dashed del x dashed, and you can show that gamma x dashed y dashed is this. Okay. Now gamma y dashed also, you can just from this you can replace del y dashed by del y dashed by this minus sine theta del x plus cos theta del y, and you operate it on v dashed, and v dashed is, where is it on here, so v dashed is minus u sine theta plus v cos theta. So from here you get the relation, or you put theta equal to theta plus 90 degree, then your x dashed will, so in this relation, so here you put theta equal to theta plus 90 degree, that means x will go to y, x dashed will go to y dashed. Here also you put theta plus 90 degree in place of theta. So if you do that, so you get this as your epsilon y dashed y dashed. So these are the three transformation relations. And what do you do with these three transformation relations? You know xy. Suppose you have one xy, and in that xy you know epsilon xx, epsilon yy, and gamma xy. Then you are given some x dashed y dashed, where the angle between x and x dashed is theta. Then what would be the values of epsilon x dashed, epsilon y dashed, and gamma x dashed, y dashed? Those you can find out by using this formulae. Now what is principal stress? Principal stress means the shear stress is 0. Shear stress is 0. Then if shear stress is 0, from here you get tan 2 theta equal to gamma xy by epsilon xx minus epsilon yy. So just gamma xy, epsilon xx minus epsilon yy, this angle is 2 theta, this is this. So cos 2 theta would be epsilon xx minus epsilon yy divided by this hypotenuse, and then sin 2 theta would be gamma xy divided by the same hypotenuse. Now you just replace this here, because for that 2 theta, for which gamma x dashed y dashed equal to 0, you put that value there and you get this relation, and when you simplify you get this as the relation. So epsilon 11 is epsilon average plus this, and epsilon 22 is epsilon 22, that means in epsilon y dashed y dashed expression you put these values of cos 2 theta and sin 2 theta, and you get this. So this is the maximum principal stress and this is the minimum principal stress. So you can also find it from the Mohr circle.